First video of Unit 9, graphing in standard form. And this is going to be different than everything that we've done in Unit 8. Unit 8 was factored form. So we are going to change our method of graphing. It doesn't mean that we'll never use factored form again. It's that sometimes we're unable to factor something, and then now we need a different method of how to graph quadratic equations. So the steps to success. The first thing you need to check if you're given a quadratic function in this format, f of x equals a times x squared plus bx plus c. First, you need to ask, can the quadratic function be factored? And if it can be factored, if you answer yes to that question, then let's do that. That's the easier way to do that. The first thing, you need to find out what are the x-intercepts. We do that by factoring and setting each factor equal to 0. We want to know what the axis of symmetry is by averaging those two x-intercepts, or just finding the middle between them. Then you want to find where the vertex is. Then you make a table and plug in the 3 points you already know, and then draw the parabola. Those are the steps all from Unit 8. So basically this entire side of the page will be Unit 8. But if it cannot be factored, if you ask the question, can it be factored, you have to answer no. Then what you want to find out is where is the y-intercept. And if you don't know how to do that, what you need to do to find the y-intercept is you need to plug 0 in for x and then solve for y. That's going to be the easiest point to get, is where is the y-intercept. And then to find the axis of symmetry, you're going to use this formula, negative b divided by 2a. And that's going to find us our axis of symmetry. Negative b over 2a, what does that mean? Well, look, here's b in the equation. It's the coefficient of the term with x on it, the linear term. And a is the leading coefficient, or the coefficient on the quadratic term. And so the axis of symmetry is x equals negative b over 2a. And then you'll find the vertex the same way by plugging in that axis of symmetry into the function for x. You'll make a table with what we know so far, and you'll have some other points. Then you'll draw the parabola. Remember, the parabola is just that U shape that we get from the graph of a quadratic function. So again, some review items here. Remember that if the leading coefficient a is positive, so that means that it's greater than 0, so a is bigger than 0, it's going to open upward. If it's a is smaller than or less than, then it's going to open downward. And finally, the last two ones, if it's closer to 0, so close to 0, it's going to be wide. If it's far from 0, it's going to be narrow. All right, let's take a look. What's the first question that we ask when you're trying to graph a quadratic function? First question, can it be factored? So we look at this equation, g of x equals x squared minus 2x minus 3, and I'm looking at the right side of this equation. I want to know if it can be factored. So I try to factor first by looking for a greatest common factor. There is none. Then I look for a special case. Nope. Then I just try to factor by guess and check. I know I have x and x to make x squared. And I know I need a negative 3 and a positive 1 to multiply to be negative 3 and add to be negative 2. So the answer to this question, can it be factored? Yes. And then if it can be factored, we're going to follow the same procedure that we did in the last time. Which way was this one open? Well, the leading coefficient is 1. We can't see it, but it's 1. So it's going to be positive, and it opens upward. And this one is going to be a normal parabola. I'm going to put that in parentheses, which means that I'm not far from 0, and I'm not close to 0. It's at that 1. So it's going to be a normal parabola. Now I know this is kind of out of order on your notes here, but we find the axis of symmetry next, which means I need to go ahead and take these factors, set them equal to 0, and find out what the x-intercepts are going to be. If x minus 3 equals 0, x plus 1 equals 0, I add 3 to both sides, I get x equals 3, or if I subtract 1 from both sides of this equation, x equals negative 1. So my two x-intercepts are 3, 0, and negative 1, 0. To find the axis of symmetry, I find the average, or the middle between them, 3 plus negative 1 divided by 2. So that is going to end up being 2 divided by 2, which is just 1. So the axis of symmetry, x equals 1. And now I'm going to go kind of back to my vertex question. What's the vertex? I take that 1 from the axis of symmetry, and I'm going to plug it in for x into this equation in red. So I'm going to go ahead and take that equation. That was g of x, which is just y. This g of x is the same thing as y. Y equals, and it's going to be x, which in this case I want to put in the axis of symmetry, 1 minus 3. And then again we have another x, 1, which is going to go down here. And I have plus 1. Then I want to simplify. 1 minus 3 is negative 2. 1 plus 1 is 2. Negative 2 times positive 2, negative 4. So when I put in 1, I get negative 4 out for y. So now I have my vertex. Step 4 is to make a table. Okay, we'll do that now. So the points I have in my table, I have, of course, the two x-intercepts, 3, 0, negative 1, 0. And now I have the vertex right here, right? So I have 1, negative 4. So I begin to graph. So I'll go ahead and draw my x-axis here, then draw my y-axis. Plot the points. I'm going to make my scale just go by, I probably have room to go by 2s on this one. 1, 2, 3, 4, 5. It just makes my graph a little easier to read. It's a little bit more spaced out. 1, 2, 3, 4, 5. 1, 2, 3, 4, negative 5. 1, 2, 3, 4, negative 5. Let's plot the points that we have. Okay, I'll do that with my light blue teal kind of color here. So 3, 0 would be my first one. Negative 1, 0 would be my other. Okay, so I have my two x-intercepts. I have 1, negative 4, which would be my vertex. My axis of symmetry is going to go right through that vertex, just like this. I need one more point, though, because I want to have 5 points in my parabola. So I'm just going to plug in another point for x, and I'm just going to plug in 0. Y equals, and it's going to be 0 minus 3, 0 plus 1. I get negative 3 times a positive 1, which is negative 3. So 0, negative 3 would be my fourth point. I get a free point by reflecting over the axis of symmetry to get 2, negative 3. Great. So that's the old way. That's from Unit 8. How I know how to graph a parabola is just by factoring it and then getting the points that way. Now, the other way, what happens if I can't factor, though? So here's an equation, f of x equals x squared plus 2x minus 5, where the quadratic expression on the right side is not factorable. So when I ask the question, can it be factored, you have to answer no. How do I know that? Well, I'm just trying to save you time. You might try to factor this, but there's nothing that multiplies to be negative 5 and adds to be positive 2. So that's how I know that it's not factorable. So I'm just going to write no here to save us time. Well, first of all, I can still tell whether it opens up or down. It's positive 1 in the leading coefficients. It's going to open up. But to find the axis of symmetry now, I'm going to use a different formula. I'm going to have to identify what the a, b, and c values of this function are. So a is the leading coefficient. It's going to be 1. The b value of this quadratic equation or expression on the right-hand side is 2. And then c is going to be this last number, negative 5. And to find the axis of symmetry, what I have to do now, instead of using the factors, I use this formula, negative b divided by 2 times whatever a is. So I have negative b, which is 1, plug in 1 for that spot, and then 2 times my a value. Oops, negative b would be negative 2. Sorry about that, guys. It should be negative b, so it would be negative times a 2, and then 2 times a, which is 1. So I have negative 2 over positive 2, which ends up being negative 1. So x equals negative 1 is my axis of symmetry. Now to find the vertex, I plug in negative 1 into the equation for x. Now notice I can't plug it into the factored form. So now I have to plug it in the normal equation. X squared, I want to plug in negative 1 for x. X squared plus 2 times x minus 5. What's negative 1 squared? Negative 1 times negative 1, positive 1. 2 times negative 1, negative 2. Then minus 5 stays the same. Now be careful, and this is where most students make their mistakes. They're going too fast. 1 minus 2, negative 1 minus 5. What's negative 1 minus 5 more? Negative 6. So my vertex will be at negative 1, negative 6. The one thing I want to do now is I can find the y-intercept by just plugging in 0 in for x. So y equals, and if I can do 0 squared plus 2 times 0 minus 5, I'll get 0 plus 0 minus 5, and I get negative 5. So when I plug in 0, I get negative 5. And when I plug in my axis of symmetry, negative 1, I get negative 6. So I can start to graph this function now. Okay, so here we go. There's my x and my y-axis. I'm going to go by, let's say, I'll go by ones this time. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm on negative 5, of course, as I'm going down. Now I'm going up, and that will be positive 5. 1, 2, 3, 4, negative 5. Let's plot what we know so far. The axis of symmetry, x equals negative 1. That's my axis of symmetry. I'm going to plot that on my graph first. So plug negative 1 in. Make my axis of symmetry at negative 1. I'll plot my point. My vertex is going to be at negative 1, negative 6. It's going to be right here. I don't know what my x-intercepts are, but I know what my y-intercept is. And I have 0, negative 5 in. Okay? So I get a free point just by reflecting over the axis of symmetry. Now I have negative 2, negative 5. But I need to plug in one more value to find the fourth and fifth points. So I'm going to plug in 1 for x into the equation. So if I plug 1 in, I'll get 1 squared plus 2 times 1 minus 5. I get 1 plus 2 minus 5. 1 plus 2 is 3. Minus 5 is negative 2. When I put 1 in, I get negative 2. So I'll put 1 in here for x. Negative 2 comes out. Free point by reflecting over the axis of symmetry, I get negative 3, negative 2. And now I have my parabola graphed in a different way, but I still have 5 points. Let's go through the process one more time. First, I want to check, can this be factored? Well, this is a tough one because my a is not 1. My a is 1/2. And I technically could factor out a 1/2 from all of this, but I'm just going to go ahead and tell you this is not factorable, at least not easy to factor, right? We've never factored ones like this. So, not factorable easily. So I'm going to write that kind of with an aside. Not easily factorable. Okay, which way will this open? Well, of course, since the a is positive, it's going to open upward. And the first thing we should try to do is let's find that y-intercept. Let's put 0 in for x. I'm going to find the y-intercept where I'm going to touch the y-axis. So y equals, I'm going to have 1/2 times 0 squared minus 0 minus 6. Of course, 1/2 times 0 squared, 0 times 0 is 0, times 1/2 is 0. Lots of zeros going on here, negative 6. So when I plug in 0, I get negative 6. Now to find my axis of symmetry, I need to identify what a, b, and c are. What's a? It's 1/2. What's b? Negative 1. Looking at just the numbers, not the x's that go with it. Negative 6. Okay. So if I want the axis of symmetry, I need x equals negative b over 2a. Now b in this case is negative 1. A is 1/2, so I multiply 2 times 1/2. And so then I get negative times a negative makes a positive 1. 2 times 1/2 is 1. So I just get 1. X equals 1 is my axis of symmetry. So then to find out what the vertex is, I plug in 1 into my equation for x. And I'm going to pause and just do that. See from my math here in orange that when I plug in 1 for x, I get negative 6.5 for y. Pause the video and copy down that work if you need to. Let's graph what I have so far. And again, I'm going to pause to save time. Here's the graph with my y-intercept and my vertex. I get a free point by reflecting over, and I have 2 negative 6s and a third point. Now I'm going to plug in another x value just to find out. And so I'm going to plug in negative 1 in the equation to find my fourth and fifth point. Follow my math over there, and you get negative 4.5. I reflected over the axis of symmetry, and there's my parabola. I'll see you tomorrow.